So we're still talking about linear and exponential functions. That ties into arithmetic and geometric sequences. Okay, so this isn't anything completely new. It's very much like 2.1. In the last section, we learned that arithmetic sequences behave like linear functions, and geometric sequences behave like exponential functions. Again, there's really not anything else for you to write on this page, but I'm going to walk you through all of this really important information. This just shows you side by side the similarities between, like, say, an arithmetic sequence formula and a linear function. And I kind of pointed this out last time. If you don't remember, that's basically an arithmetic sequence. The way that it's written is like mx plus b, just kind of swap them. The initial value is your y-intercept, multiplied by, and I kind of mentioned this last time, the common difference. That's the same thing as the slope. If we were to connect the dots in dotted line, the common difference is just the slope. So you can see the similarities there. And then you may not have noticed, I did not say this last time, that when we write kind of a general form of an arithmetic sequence, it's very similar to point slope form. We've just moved the y value over to the right. Okay? Because typically you would see like y minus y1 over here. Once you move that y1 value to the right, look how similar it is. They're the same exact thing. Geometric sequences. Here is probably where I'm just going to need to spend a little bit more time, because people are way more comfortable with linear functions than they are exponential. Here is how you learned to write exponential functions in algebra courses. It's some number multiplied by the base of the exponent, and the exponent itself is the variable. Well, we've got the same thing going on over here. If you have the 0th term, look how similar those are. If you don't have the 0th term, I really don't think you were exposed to this before, so that's okay. Just to show you the similarities there. It says it's important to recognize and understand the similarities and differences between linear and exponential functions. So here again we have linear versus exponential. Here are those word problems, the vocabulary, the wording. This is going to be very important to you. You are going to see a table of values, and if you find that over equal length input value intervals, in other words, if the x's are going up by the same amount each time, and you find that the output values or the y values are changing at a constant rate, that's a linear function. That has been embedded in this course since the very beginning. What's going to be new information for you as of today, look over here for exponential functions. If you see a table of values and the x's are all going up by the same amount and the output values change proportionally, and to you, that just means, am I multiplying by something every single time? If you are, the way that you write that in words is the output values are changing proportionally. Then that's an exponential function that you see. On a linear function, the change from each y value to the next is based on addition. Subtraction is addition, guys. So that's basically addition or adding a negative number. So addition/subtraction. You're going to notice you've got an exponential function if the change every single time is based on multiplication. Proportionally, that just means we're multiplying by the same amount each time. It's being raised or decreased proportionally to the last term. It's a proportion. Just look at that word and think multiplication. Okay? And then the word problem, here's how you're going to tackle those. If you've got 2 points, and have this big paragraph, and you're going to kind of weasel your way to, oh yeah, they're really just telling me a couple of terms. If you've got 2 points, then write the equation of the linear function, exponential function, and then that's just going to lead you to either an arithmetic sequence or geometric sequence, depending on the directives. what is it asking me to do? Those are really easy because you've done it before. Turn the page. What does all that mean? Example 1 says, selected values of several functions are given in each of the tables. For each table, determine if the function could be linear, exponential, or neither, and then just give a reason. So we're going to be very consistent in how we write this so that you get used to either writing it on a free response or picking out the multiple choice, like the correct wording on multiple choice. On A, the x's are going up by 3 each time. Okay, so those are equal length input intervals, consecutive equal length input intervals. And then what pattern do you notice here? We're subtracting 2, subtracting 2, subtracting 2, subtracting 2. Is that a common difference or a common ratio? That's a common difference. Is the change in the rate, is it constant or proportional? It's constant. Could this be linear or exponential? Linear. And here's what we're going to write. This could be linear because the output values are changing at a constant rate. We've written that in some notes before. We had notes that compared linear to quadratic. How to tell if the table is linear or quadratic, or cubic, or quartic. That's when you went out all the way until you found a common set of differences, and it asks you what degree could this polynomial be. It's the least degree. Okay, moving on. Well, if I start with just addition, adding 1, adding 3, okay, that, I'm going to go ahead and just write my thoughts. Oops, adding 1. Adding 3, adding 5, adding 7. Is that linear? Mm-mm. Now, am I multiplying maybe by the same amount each time? No, because 0 to 1, I mean, what are you multiplying? You know what I mean? There's no way that this could be exponential. Could you recall some old information and tell me what degree this polynomial could be? It could be quadratic, it could be second degree, because if I went out one more tier of differences, I would find that the rates of change are constant. But that's not really what we're having to do here. If our options are linear, exponential, or neither, we're going to put neither. Because the output values are not changing constantly or proportionally. They're not changing constantly or proportionally. I'm adding 1, I'm adding 2, I'm adding 4, I'm adding 8, but, so it's not linear. Now I need to check for exponential. Is there a common ratio? Something that I'm multiplying each time by. I'm doubling it. Hi. So you know what to write, go for it.